Alright, so if we were to rewrite this integral as x to the negative 1 dx and then try integrating, you said we would get x to the 0 over 0, right? And does that work out for us? No, okay. So nope, it doesn't work. So we always have to go back to Old Faithful and remember that what that integral symbol is kind of telling us to ask ourselves. Okay? Remember that it's always telling you to ask yourself, whose derivative is 1 over x? So sometimes thinking of the question like that makes it easier. Whose derivative would be 1 over x?
ln of x.
ln of what?
X.
Of x, right? Okay, so then we can go back to that same problem and ask ourselves again. The integral of 1 over x dx should be what?
ln of x.
ln of x, right? Because that's whose derivative this would be. Cool? Now the problem arises when we start thinking of those x values, right? What is it that we can't have there for that? What is it that we can't take the ln of? Negative numbers or 0. Can we take the ln of 0? No, okay? So this is a problem because I can divide by negative numbers over here on this function, right? Negative numbers are part of the domain of this function, but they're not part of the domain of this answer. So I gotta be careful, okay? So I gotta be able to fix that integral when I take the integral of it, so that I don't end up with negative numbers. Okay? So if we think about the graph of ln of x, so you can understand why that's happening. Okay, the graph of ln of x looks like this. So what would the domain of that ln of x graph be? X is greater than 0?
Yeah.
Very good. Okay, so again, going back to the fact that the values had to be positive, right? They couldn't equal to 0 and they couldn't be negative. It's not part of the domain of that function. Okay, so if we know that that's the domain of the ln function, then we can say that the integral of 1 over x dx is actually equal to ln of the what of that x? Why do I have to put that absolute value? Why do you think? To make sure that these values that are going in here are going to be what? Be positive. Because over here on this original function, they could have been what? Negative numbers. We understand? We have to have that reassurance. Now sometimes you get an equation like, let's say x squared plus 5. That will never be negative. Okay, so technically there, would the absolute value be necessary if I had x squared plus 5 in there?
No.
No. But to be on the safe side, it's always good to just what? Put that in absolute value there. Get into the habit of putting it there. Now there may be an answer choice where it doesn't have the absolute value there. Again, going back to that understanding that that argument could never be negative because of the way it was written. Therefore, there's no problem. There's no need for the absolute value. But to be safe, it doesn't hurt to put them. They won't take off points if you put them and they don't need to be there. So just always put them. You understand? Cool? Remember that it's plus what? Let's see. So there must be a positive. So that means up here on the top, we gotta fix this one, right? We gotta change those parentheses to what? Absolute value bars, and we have to put plus what? See, because we kind of forgot that one. Cool? Got the idea? So if I can get any problem to end up looking like 1 over something, 1 over u, right? Then the integral of that will always just be ln of the absolute value of u, right? So this is where u substitution comes into play to help us rewrite some problems. So they look a particular form and then we can integrate them easily. Alright, so looking at this first one, what would we consider to be u in this here? X squared plus 1. What would we consider to be du? 2x dx. So in this problem, we could use the shortcut of pattern recognition. Do we have the license to integrate? Is that 2x there?
Yes.
Yes, and the dx, right?
Yes.
So those parts kind of go away, so it's like having the integral of just 1 over u du, because the other parts went away. We still had a u in the denominator. What would the integral of that be? Ln of the absolute value of u plus c, and now we can just replace that u with x squared plus 1. Super easy? What do you think? Maybe? Let's try this one. What would we pick for u to be? 3 minus x cubed. What would du be? Negative 3x squared dx. This is a u. I got an x squared and a dx, but I don't have a negative 3. So we need to have a negative 1/3, right? To be able to balance that out. You with me? This is like what we did yesterday where we would put a 3 there. We put a negative 3, but then we would put a what on the outside? A negative 1/3, right, to cancel it out. So you could continue doing that if you have that license to integrate. So we would get negative 1/3 the integral. This goes away of 1 over u du. We're ready to go. Super easy. What's the integral? Negative 1/3. Ln the absolute value. Can I already put what u is?
Yeah.
3 minus x to the 3rd plus c. Too easy? Let's get 3. What are we going to pick for u to be on number 3? What did you pick? Just ln of x?
Yeah.
Yeah? Why?
How you can cancel out?
The derivative of x
Huh? The derivative of ln of x is going to be 1 over x. Is 1 over x present in my problem?
Yeah.
Yeah, very good. So picking just this part right here to be u is a good decision. Because du is going to be 1 over x dx. Do I have both of those things? Yeah, I got it right here and right here. So both of those are going to be taken care of as long as I replace it with du. So we still get the integral of 1 over u. So we end up with what? Ln of the absolute value of what was u?
Ln of x.
Ln of x. We get ln of the absolute value of ln of x. Cool? Too easy, guys? Number 4. What do you want to do there? What do you want u to be? Shall we rewrite it first? This will be the integral of x times 9 minus x squared to the negative half dx. Right, so you want u to be 9 minus x squared? What's the du going to be? Negative 2x dx. Alright. So this is going to be taken care of with u. We got an x and a dx, we got to get rid of this negative 2, right? Negative half du is equal to x dx. Those guys are taken care of. Everything good? We have the integral with a negative half on the outside times u to the negative half du. Do I have to use anything with ln on this one? Huh? No? Okay. What do we get here? Negative 1/2 times u to the half. We add 1 times 2 plus c. 2's go away. Negative parentheses 9 minus x squared to the half plus c. There was nothing with ln on this problem. Okay? Don't think that just because we're doing ln, everything's gonna have an ln in it. Okay? Can't forget the stuff that we learned before. So far so good? Pretty easy? You got this? Now let's look at these bad boys. What would I do for these particular problems? There was one like this on your test, except that on your test it had limits. So after you integrated, you had to evaluate.
Yeah, I got that wrong.
You got it wrong? Only 2 people got it right in second block, but I think it was because they just guessed correctly. I don't think they really knew how to do it. We hadn't talked about it. And I was actually gonna leave it out, but after I saw it on the mock test, I was like, no, I better go back and put it. The only part that I'm leaving out is the part with the long division. I didn't do any of those examples, so I'm hoping that they don't give you one of those. I really thought that they will. If they do, I'm sorry. Hopefully you can remember long division. Okay. So if we look at a problem like this, so first thing I start out by doing is checking to see if I can simplify it, okay? So can I simplify it? Can I factor and cancel something out? Is the top part factorable? No, because we want to multiply to get a 1, but add to get a 3. And that's not possible, because 1 plus 1, the most it could be is what? 2. So it's not factorable. Okay, if I make the bottom u, x plus 1 as u, the derivative is just dx. That's not going to really help you with anything. And I don't want to have to replace x up there with something in terms of u, because that's going to get nice and crazy. Cool? So, the way to get through this problem is to actually divide it. Right? We have to use something called synthetic division, or in this case we can, which is the shortcut to long division. Okay, we can only use this when you're dividing by something that looks like x plus or minus what? K. Something that's linear. Okay? And I don't even know if you remember how to do this. Anybody remember? You and UIL don't answer. The L thing. So you make that big L, so make an L like this, guys. For Longhorns, and put it right here on your forehead. Awesome. Okay? So the next time you're at some of our football games, you throw that Longhorn symbol. Go Longhorns! Woo! Okay? Got it? It's like it's our new symbol, okay? The Lariats are doing it. Go Lariat, Longhorns! Woo! Okay? Alright, so inside this L, what you're going to put is the coefficients of each term in your polynomial on the top. Okay? One thing you want to make sure is that all the powers are there. Each term is present. So if it starts at the second power, I better have the part that has to the first power and the part that has to the no power. If one of them is missing, I need to replace it with what? 0. With 0, which is the most common thing that is forgotten, and people get it wrong because of that. So here, do I have all my terms?
Yeah.
Second power, first power, no power. Alright, so put the numbers. What's the number in front of the x squared? In front of the x? In front of the nothing? You're confused? On the outside, okay, what you're going to put is what we're dividing by, which is this guy right here, equal to 0, which is going to end up being negative 1. That's the number that goes in here. Is it coming back to you?
Yeah.
Yeah? Should have done this in pre-cal when you were looking for slanted asymptotes or oblique asymptotes. Sometimes you had to do this by long division.
Like a few times.
What is that? So anyways, we bring down a 1. The first number always comes down automatically. Okay, and then you have to remember, mama, You guys remember mama? No? Mama.
Multiply, add.
That's a new one. Multiply, add. Multiply, add. Multiply, add. So you keep saying mama, mama, mama as many times as you need it. Okay, so we bring this number down and we say ma. So multiply times this guy, that's -1. And then we add. So 3 plus -1, 2. And then we multiply again, -2, and we add. -1. Sometimes I come up with these things on the fly. Okay? Your answer, okay, will always be 1 degree less. So if this was x squared, this is going to be x because you're dividing by just x, okay? So when I divide this by this, I get x plus 2, but I have this guy over here which is called our what? Remainder. Okay? And I don't know if you remember when you did long division. Let's say we did 25 divided by 3. Okay, we said how many 3's go into 25? 8. And how many, what would that give us? 8 times 3? 24. And then we would change its sign, right?
Yeah.
So we would make it negative. We'd have 1 left over. So the answer was 8 plus the remainder 1